So today we want to integrate e to the x minus 1 over e to the x plus 1 from 0 to 1 with respect to x, and we want to use substitution in order to solve this integral. So firstly, what we are going to do is we multiply both the numerator and the denominator with e to the minus 1/2 times x. And that gives us the integral from 0 to 1 over e to the 1/2 times x minus e to the minus 1/2 times x over e to the 1/2 times x plus e to the minus 1/2 times x dx. And this is just the integral from 0 to 1 over 2 times sine hyperbolicus of 1/2 times x over 2 times cosine hyperbolicus of 1/2 times x dx. So the 2's cancel out, and now we are almost ready to substitute. So the function we want to substitute is cosine hyperbolicus of 1/2 times x. I will write it here. I will call it phi of x. We want it to be cosine hyperbolicus of 1/2 times x. So we know that phi prime then equals 1/2 times sine hyperbolicus of 1/2 times x. So, and we have to find the derivative inside the integral, but we only have sine and not 1/2 times sine hyperbolicus of x, so we need to multiply in the integral with 1/2, and so to not change the integral, we need to here multiply with 2. And then we have 2 times the integral of 1/2 times sine hyperbolicus of 1/2 times x over cosine hyperbolicus of 1/2 times x dx. So now if we substitute, we of course then only have 1 over z dz, but we also need to change the boundaries. So we need to compute those, and we have phi of 0 equals cosine of 0, which is just 1. So lower boundary is 1, and then phi of 1 is cosine hyperbolicus of 1/2. So we can't simplify that and just put it in the upper boundary, cosine hyperbolicus of 1/2. And now we integrate, and what we receive is 2 times the ln of the absolute value of z, the boundaries from 1 to cosine hyperbolicus of z, of 1/2. So now we plug in the boundaries, and we end up with 2 times natural logarithm of cosine hyperbolicus of 1/2. So note here that we can leave out the absolute value because cosine hyperbolicus of 1/2 is bigger than 0. And now we need to subtract the natural logarithm of 1. So we know this is just 0. So what we end up with is just 2 times the natural logarithm of the cosine hyperbolicus of 1/2. So the integral looks quite complicated, and maybe the result isn't that simple, but I think if you just got the trick once, it's not too hard to solve.